Unit 2, the atmosphere. For day 5 of class, we're going to work on our first section of observing weather, all about pressure. So for learning target 2.e, we're going to be able to identify high and low pressure areas on a map, describe why high and low pressure areas exist, read a thermometer, barometer, and psychrometer. So air temperature. This is measured with a thermometer. When it is hot, the liquid inside the thermometer will expand and rise in the tube. When it's cool, the liquid inside the thermometer will compress and sink into the tube. Air pressure. This is the force exerted on you by the weight of tiny particles of air. When air is compressed, air is said to be under high pressure. Forecasters measure air pressure with a barometer. Okay, so basically how it works, when the pressure is high, it pushes down on the liquid here, which sends it up the tube, which will give us a higher reading. When there's not a lot of pressure, or it's low pressure, the liquid doesn't get compressed as much, so it doesn't go as high up the tube, so it would be a low pressure. We use isobars on a map. These are going to connect points of equal pressure, and we will have practice drawing those onto a map. So reading air pressure, it's typically measured in millibars, okay? And it's used with a barometer, that's what this is up here. And our average pressure at sea level is 1013.25 millibars. Okay, so when we look here, these black lines, these are isobars. They are connecting areas with the same exact reading. So this one says 1020. That means all along this line, the pressure is 1020. This one's 1015. That means all along this line, it's 1015. Okay, and so on. So humidity. Relative humidity is measured using a psychrometer. It compares dry and wet bulb temperatures. In other words, you have one thermometer that is dry. You have another thermometer that is being affected by water. Okay, so there's a wick that's dipped into water. So the wet bulb is cooled by evaporation. The drier the air, the cooler the wet bulb. Moisture in the air. Water is present as a liquid and a gas in the atmosphere. The amount of water vapor in the air is called our humidity. The amount of water vapor the air can hold depends on the temperature of the air. Warm air can hold more water vapor, while cold air cannot hold as much. Water vapor is less dense than air, so it always rises. Wind speed is measured using an anemometer, and wind direction is measured using a wind vane. This over here is an anemometer, so it has like little cups on it, so when the wind blows, it's going to catch it, and how fast this spins will tell us how fast the wind is blowing. And wind vanes, most of us have seen those on the top of farms and things like that. So when the wind blows, it points in the direction the wind's going. Okay, so winds are named by the direction they come from, just like you. I come from Virginia, so I'm a Virginian. A wind blowing from the north is a north wind. So our air masses. These are large sections of air that have the same characteristics, including our temperature and humidity. So we name them after these two characteristics. Our temperature. Air coming from the poles is cold and contracted, so we're going to call it polar. We use a big P for that. Air coming from the equator is hot and expanded, so we call it tropical. We use a big T for that. Air coming from over any ice caps is very cold, so we call it Arctic, and we use a big A. When we look at the humidity, it can either be very humid or it can be very dry. Air coming from over the ocean is humid, so that's maritime. Okay, that stands for oceans, and we use a little m for that. Air coming from the land is dry, so we use continental for that, and we use a little c for that. So when we look at the United States, which is here, okay, you can see we have different combinations of these letters. So our continental polar, our little c, big P, is coming from over Canada. Our continental Arctic is coming from the North Sea over the North Pole, so a little c and a big A. Maritime polar, okay, so humid air for the maritime, polar, big P, coming from cold areas. We have another maritime polar coming from this area. Now, our warmer things, which are going to be our tropical, okay, our maritime polar, or maritime tropical, which is going to be warm and moist. Continental tropical, this is coming over from just land, so it's continental tropical. And then you have two more maritime tropicals. Air masses and pressure systems. Unequal heating between air masses causes air to rise faster in some areas and slower in others. This results in differences in air pressure. Remember, we've been over this before. Rising air is going to cause low pressure because you're taking the air away. Your sinking air is going to cause high pressure. Wind is always going to blow from your high to low pressure. Our air pressure systems. Our high pressure systems. This is, remember, where we have sinking air. So our cool, dry air descends towards the surface and moves away from the center in a clockwise direction in the northern hemisphere. This would be opposite in the southern hemisphere. Our low pressure systems, where we have air rising, is going to have warm, moist air ascends away from the surface and moves towards the center in a counterclockwise direction in the northern hemisphere. This would be opposite in the southern hemisphere. When we look specifically at our high pressure systems, these are formed from cool, dry, sinking air. We also call them anticyclones. They're usually associated with fair weather. Fair weather just means that you have clear skies and the sun is shining. Our low pressure systems, these are formed from warm, moist, rising air, and we call them cyclones. These are usually associated with storms. Because I'm taking that warm, moist air and it's moving upwards, this is what's going to form all of our clouds and cause it to rain. Okay, so when we look, these are our high pressure systems. These are our anticyclones. Your air is coming down and it's moving in a clockwise direction. Your cyclones, or the ones that are going to cause storms, are called low pressure systems. So you have air rising and it's rising in a counterclockwise direction.